Okay, we'll move on to the next type of problem in case of pyramids. A freely suspended pyramid. So, the exams they're going to give you about a particular point, that a corner, freely suspended about the base corner. That's the most of the problems that will be given in the exam. We'll see how to solve that problem. If a pyramid is suspended freely about a corner of its base. So in that case, say if you are keeping your pyramid something like this resting on HP, and if you suspend about the base corner, so then it will turn down. Okay, so we can see that it will go to bend in this direction. Okay, so in that case, better to keep the solid to rest on its apex on HP, so that when I say suspend about the base corner, the solid should automatically turn like this. So then the turning of the pyramid will be very limited. Okay, so this will be limited and it will turn by this position to this when I freely suspend about this corner. So again we'll observe that when it is freely suspended, a point of the suspension and a point on the axis which is 1/4 from the base will become actually perpendicular to horizontal plane. In case of the prism, the same thing was actually if you freely suspend about any corner of one of the end faces, then the point of line joining the point of suspension and the midpoint of the axis line, the midpoint of the axis used to become a vertical, whereas here, so 1/4 of the axis from its base somewhere here, so on the axis and the line joining of this particular point where you suspended, and that point on the axis which is 1/4 from the base, take that line joining between this corner and the point which is 1/4 from the base, then that will actually become vertical when you freely suspend any pyramid. So for that, better to keep the pyramid to rest on the apex, then you just turn or just you lift this about the corner, freely suspended about HP, so it will going to incline in this position. So for that I will go for the procedure. Any pyramid, this will be the procedure. Always they are going to give you a pyramid. I'll go for a pentagonal pyramid. A pentagonal pyramid of say 30 mm base edges and height of 70 mm, then let's say it's resting, is freely suspended, is, so the dimension of the pyramid will be given. Need not be a triangle, pentagonal pyramid, any pyramid, the same procedure, right? A pentagonal pyramid of 30 mm base edges and a height of 70 mm is freely suspended about a point, or freely suspended about a corner of its base, such that the axis is inclined at 30 degrees to VP. So in any freely suspended problems, whether it is a prism or a pyramid, so the axis inclination will be given only with the VP, vertical plane. So in this case, whenever you have any pyramid, go for actually keeping the pyramid to rest on its apex. So completely reverse. Previously used to keep the pyramid resting on its base. Now let it rest on the apex. I'll go for solving that. So in that case, if you want to say suspend a pentagonal pyramid about a corner, so you should have a corner, let that corner to be on the left side when you suspend, so the solid should turn towards right. Okay, so in that case you go for a corner position on the left side. Okay, so anyway this is the edge position, so that you're going to have a corner on the left side. Okay, so previously when I say the corner position, we used to keep it on the right. whereas in this case you should have a corner on the left. So you can keep that actually on the corner on the right. Okay, so when you tilt, it will going to tilt something like this. You can go for that. If you're getting confusion, better you can go for having that corner, the corner position. When I say let it be in the corner, then you can bend, it will turn towards left. That's the only difference, so need not worry about that. Okay, if you're getting confusion, we'll go for that only. So even in this case, when you suspend, it turns towards right, because I used to solve the problems turning towards right. That was the best method. Otherwise we'll go for having any pyramid, so let it be the corner position. When I say the corner position, we're going to have a corner on the right side. So corner on the right side, let it be, no problem. So this is A, B, C, D, E. Even you can take this also, but I'll see for time being, let it be this way. Because the corner position, so you should have a corner on the left side if you want to have the solid to tilt towards right, whereas in this case you have a corner on the right side. That's what the corner position you used to say. So then you will go to lift, then the solid will bend towards left. That's the only thing. So let it bend for this particular position towards left, no problem. So this is the axis, project all the points. So because I said to have the apex on the ground, let it rest on the ground. So I'll move up, project all these points up through a height of the solid. So then you have the base at the top. So in that case this will be the wrong. Okay, I'll just tell you, let it be, should so project this, let it be, I forget. So in this case, because on the base you can see the complete surface, there will not be any edges visible because it is the reverse. So kept like this, corner position on the right. Okay, so you cannot see it because this is complete solid. You will not see that inclined edges. So in that case, so all the inclined edges should be a dotted line here. For case of the pyramid, let it be all these lines are dotted lines. Getting that? Okay. So let it be a dotted lines. So O and O1. So this is O and this is O1 now. A, B, C, D, E, all dashes. So C, B, you can see A, E in the bracket. Right? So all this should be a dotted line. So don't join them with a thick continuous line because so it is reversed now. It's not resting on its base. Instead, it is resting on the apex on HB. So resting on its apex, right? So then you can see the base completely. So there should not be any arch in the visible end face, visible base. So that's the one. So then you say if this is 60 mm, 1/4 of 60. So mark the point. So then get a line joining of this. Let it be very thin. This is only the construction. So the corner. So this is the line joining between the point of suspension. So this length should be always 1/4 of its axis from the base, not from here. So 1/4, if it is 80, it will be a 20. If it is 60, 1/4 of 60. So that is 15, right? Okay. So at 15 mm from the base. Okay. So then I in the same procedure as in case of prisms, you have to draw is very well above so that nothing should touch your XY line. So freely suspended, it should suspend above the ground. So it should be above the ground. So nothing should rest on HB. In that case, I'll go for having this construction of this. So anyway, I know this length. I can take this length and draw a vertical line. So let it be very thin. This is not important. So go for marking that point. So this is D dash, whereas this is the point. I'll say point some P, right? So this is P. That's not important. When you bend like this, always it will turn towards left. Okay, so that's why in this case it will be turning towards left. You should not confuse. Always you used to bend towards right. Instead, in this case, it will bend towards left. That's why I was going for actually this, so that when you tilt about this, it will bend towards the edge side. Okay, always on the edge side. So this is the edge. So it will be, because there will be more volume. So it will, the axis is, see, very close to this. So the weight will be more here. So that bends towards that. So then you have to go for drawing that. Taking this P2 O dash, draw an arc. Then D2 O dash, draw an arc. So get that O1. So O1. So this is O1. Then extend that line. Okay, so this is, take that length and you transfer here to get that AP. Then you can go for marking the D to C. So this is C and E, right? So now we can go for constructing this triangle. So I know this length, draw an arc, take this length and draw an arc. Okay, so otherwise on this extension you can just go, because this is now will be 15 mm. Same thing I have taken out on this 15 mm, extend that length by 60 on this 15 plus 45. So then I can join like this also. I can draw in any way. So get your view, same view which is drawn over there. So now this is the view which is redrawn now. So O1. So in this position you can observe that this axis is inclined with HV, right? Okay, so this is inclined with this much angle with HV. So then what will be the axis length on the top view? It will be apparent length. So unless they specify that particular 3 sentences appears to be inclined, or projection of the axis on HP, or the top view of the axis inclined to VP, or the plane containing that edge or something like that. Okay, so if they don't mention, then because the axis will be apparent, the given angle what they give in the problem will be a true inclination. Since the axis will become apparent here, the inclination with VP, I told you that in these problems, suspended problems, only the axis inclination will be given only with the VP. So if you don't find that sentences, 3 sentences, so along with that inclination what will be given in the exam, in the question, then you have to go for finding the beta angle. So this is simply something like this. A pentagonal pyramid of 30 mm base edges and height of 60 mm is freely suspended about a corner of its base, and the axis of the solid pyramid is pyramid, right? I said pyramid, or maybe okay, forgotten because so the axis of the pyramid, I'll repeat otherwise. A pentagonal pyramid of 30 mm base edges and the height of 60 mm is freely suspended about a corner of its base, such that the axis is inclined at 30 degrees to VP. Without the 3 sentences, if they say axis is inclined at 30 degrees to VP, since this the axis will incline, the projection of that will be apparent. So then you have to go for finding apparent beta. If you find the 3 words, no need to take beta, right? So these are the invisible edges not joined. So go for checking out the edges which are not joined. So when they say now only the axis is inclined, so then to go for finding beta, right? So go for taking this length. Anywhere you can mark from here or anywhere at the point. If you want to start the view from this point, you can take that as O, then you take the true length over here, true length of that, okay, 60 mm. You can draw it parallel. Previously I used to keep this here, no problem, anything, okay. So in that case, taking this apparent length, if you cut here, So then this will be the line joining from this point, exit point, to this axis. So now this will be the axis line. So then this will be the angle beta. No more than that. This is phi VP. Right? Okay. So anything you can take here, take the tool and draw this angle. Then if you project, you want to connect here, then you can easily know that the alpha and the phi and beta difference. But I will start for taking this point, because otherwise, that way I will be drawing. So then you may not worry here. So we'll draw now for this axis. Forget about this. Perpendicular to the axis. Go for taking this length. Mark that as a 1, 2, 3, 4. I'll inscribe in a rectangle. 1. That will be same 2 here. Then draw parallel to this. Take this 2 to 3. So this is 2 to 3, right? So 3 and 4. Let it be very thin. What do you draw here, right? So then 4. This will be 4 to A. Mark the point. This is 4 to A. This is 4 to B. Then 4 to E. Sorry, 3 to B, right? Okay. This is B. 4 to E and 3 to C will be same. So I can get this C and E. And on this axis line I have this D. So get that. So I can easily redraw if I inscribe pyramid in a rectangle. So we can see axis is overlapping here. So this is O1 and this is O1. So drawn at beta, note it. So when you draw here, they are passing through this. So this is phi and this will be the beta, right? You can start anywhere. So once you project, so need not be only the base. Always have problem. Many problems only the base near to the observer will have a problem. Base near to VP. So move up. Go for drawing that. Always. So where the base is nearer to the observer, the base is visible, right? Oh, and above also not drawn here. Okay. So this is. Then this is A, right? Okay, so A and A dash, B and B, B dash, C and C, this is C dash, D and D, D dash, E and E, E dash. So O and O, so this is O1, actually O1 and O1, so this is O and O, so this is O dash, O1 dash, and O dash. So now again the base is nearer to me compared to the apex. So then the base edges are visible. Go for drawing all the base edges with a thick continuous line. Then we'll go for drawing outermost edges. This is outermost compared to this, so we will draw that. So now this will be a dotted line because there should not be any thick line on the hand face, because there will not be any edge in the base, right? So what about this? This is visible. This is visible, and this will be the invisible edges. This is C. You can see the B will be the nearest edge. So you can see actually when you're looking from the otherwise. So this is the visible end, and this is the other end point of this OB that is visible that way. Okay, so you can go for drawing this. So this procedure is same for any pyramid. So always when you have any pyramid, triangular, square, rectangular, pentagonal, hexagonal, any pyramid, go for the corner position. Let it be corner on the right side. So if they say in that all the pyramids, they'll say that the pyramid dimension will be given, and they say which pyramid is, and they say is freely suspended about a corner of its base such that the axis is inclined at 30 degrees to VP. So since they say and axis is inclined at 30 degrees to VP without that word, then you have to go for taking beta. If they say instead of that freely suspended and the axis appears to be inclined, then you need not go for taking beta directly at that given angle. You can draw then appears to be inclined 1, then top view of the axis is inclined with VP. They say sometimes the top view, for the top view the other word. Projection of the axis on HP is nothing but the top view only, that will be given. The plane containing the axis and the edge, the topmost edge OD is nothing but this, right? Okay, so that is inclined. Incline that with that given inclination. So same 30 degrees, you can redraw this view, get your final view. The same procedure for any pyramid if it is freely suspended. Let's stop it here. In the next class, we'll move on to cylinders and cones. Cylinders will be same as the prisms and cones will be same as pyramids. So just will solve 1 or 2 problems. You can easily understand. I'll explain all different procedure, but I'm not going to draw the view, but the same procedure. We'll see. I'll just tell you what is the difference between. There will be a procedure, a lot of procedure to draw. There will be a maximum work to draw because you have to draw in freehand ellipse. Similar to the projection of planes where you have drawn that circular lamina appearing as something like an ellipse. In the same way here you're going to have 12 points to be projected in all the sides. That way the time taken to solve the problem will be more, if otherwise it is same as the prisms. Cylinders and cones will be same as the pyramids.